Hello there, Mr. Sutton here. I'm bringing you the IM3 Chapter 5 Quiz 2 Extra Practice Number 2 solutions on graphing polynomials. To sketch the graph of this polynomial, let's start by getting the roots, whatever zeroes out my factors. So for this first factor, that's -2 for the x value. And then for the next one, we have 5, because 5 minus 5 is 0. Putting those on my graph, we've got -2 somewhere to the left of the y-axis, and 5 is somewhere over on the right. Not drawn to scale because this is just a sketch. Now we need the y-intercept as well. So to get that, we plug 0 in for all the x's up here. Basically, then you're going to have a negative, a 2 squared, and a -5 all getting multiplied together. So this is -4 times -5, which is 20. And that's somewhere above the x-axis. Next, let's get the end behavior. To do that, we just see what we're multiplying together for x's and also for that negative out in front. So we have a negative x squared times an x. And this is basically, we're just trying to get the lead term here if we were to multiply all this out. But we're doing it without multiplying everything out. We just want that very first term to get the degree of the polynomial. So this comes out to a negative x cubed, which in general is negative x to an odd power. That's the important piece here. That tells us that this is going to behave like a negative x, like a downward sloping line, so that we're starting above the x-axis and ending below the x-axis. Now for the root behavior, taking a look at the exponents on each factor, this -2 is a double root because we have a squared factor, so that means we're bouncing at -2. And then 5 comes from a single power factor. This is a first power here, so that means we're crossing through x equals 5. All right, so starting above the x-axis, we said we're bouncing at -2. Now we go through that y-intercept, and we cross through 5, which leads us to end up below the x-axis, which is where our end behavior predicted we were going to end up. In order to graph this polynomial in standard form, we need to get the roots, which is going to require us to factor it a bit. I can take out a common factor at the very beginning, and that's what I should always do if I can. These all have at least an x cubed for the variable. So if I take out that x cubed, that leaves me with an x squared for that first term, minus 2x, minus 15. And now I can factor a little more inside there. I need factors of -15 that add up to -2. I believe +3 and -5 would do the job. There aren't too many other choices. So we can have x cubed in the beginning still. Don't want to lose that. X plus 3 and x minus 5. Zeroing out each factor, that's going to give us roots of 0, -3, and +5. And putting those on my graph just to see what we're looking at here. -3 is somewhere here to the left of the y-axis. 0 is the origin, and this is also going to count as a y-intercept because it's on the y-axis as well as the x-axis. And then over here to the right, we have the x-intercept 5. So we just said the y-intercept was 0. Now, another way to figure that out is if you look at the standard form expression here, we have an invisible +0 for the constant here. If you plug in 0 for all the x's, all that's going to be left is that invisible +0. So that's another way to find the y-intercept if it didn't happen to be an x-intercept as well, which it isn't always. All right, so now the end behavior, we look at the lead term of the standard form polynomial for that. X to the 5th is our lead term. In general, that's a positive x to an odd power, which means this is going to behave like a y equals x, like a line sloping up. So we're starting below the x-axis and ending above it. And now for the root behavior, going from left to right here, -3, that came from a single power factor, so we're going to cross through -3. For 0, that came from this x cubed, that's a triple root, so we're going to flatten through 0. And then the last one, 5, that was another single factor, so we're going to go just cross through that, that's a single root. So starting now below the x-axis, we cross through -3, come back up and flatten through 0, come back down, come up, and cross through 5. And we end up above the x-axis, which is where our end behavior said we would. For this problem, we just want a possible equation for this polynomial graph. So let's start by getting the overall sign of the polynomial. since our graph is going down as we move to the right, that means this is going to be negative overall. So we have y equals negative, and now I have to write in some factors here. So we see that we're going through the root of negative 4. That means we have a factor of x minus negative 4, or x plus 4, as it were. And since we're crossing straight through, that's a single root. So we just have x plus 4 to the first power, which we're not going to bother writing because it's just an invisible 1 for the exponent. Next, we're going through positive 1. So that's a factor of x minus 1. Since we're flattening through that, that means that 1 is a triple root. So we have x minus 1 quantity cubed. And then finally, we're going straight through 8. So that's going to be x minus 8 first power. For this problem, we want the specific equation for the polynomial in this graph. So to get that, I'm going to write a possible equation with all the roots and multiplicities factored in. But I'm also going to put an a out in front just to represent a mystery constant that I need to find. So let me figure out first the overall sign of this polynomial. Since we're going up as we move to the right, this is a positive function. So I'm going to write y equals positive a. And now I'll put in a bunch of factors with x's as well. We have a negative 6 as our first root coming from the left. So that means we have a factor of x plus 6. Since we're crossing straight through negative 6, that's a single root. So we have x plus 6 to the first power, which I'm not going to bother writing the 1 up there. Next, we're going through negative 2. We're bouncing off of that. So that's going to be an x plus 2. And since we're bouncing, that's a double root. So we have x plus 2 quantity squared. And then finally, we're crossing straight through 3. So that's just x minus 3 again with the first power, just like our first factor of x plus 6. All right, so I've got kind of a rough form for this polynomial. I still need to figure out that a value, though. To get that, I'm going to plug in the point that they gave me down here, 0, negative 5. So I've got negative 5 for a y value. And y is negative 5 when x is 0. So I've got a times 0 plus 6. 0 plus 2 squared, and 0 minus 3. Cleaning up the right side, we've got basically 6 times, 2 squared is 4, so that's 24, times negative 3 is going to be negative 72, so that's negative 72a. And then dividing to get a by itself, we've got 5 over 72 for the a value. And now let's just plug that back into what we wrote in the beginning here to get y equals 5 over 72 times x plus 6, x plus 2 squared, x minus 3.